All right, everybody, this is 8.3, Piecewise Functions, Part 1. All right, so piecewise functions basically is when we have different equations that have different domains. All right, so until now, all of your graphs have been represented by a single equation. But in real life, oftentimes that doesn't fit. So we can combine different parts of equations to model the situation, okay? So here is like an example of a piecewise function. So the top part is this equation, 2x minus 1, but it only applies when x is less than or equal to 1. And when x is greater than 1, we will use this equation, all right? So that's what we mean when we have piecewise functions. This function, like I said, is defined by two equations, all right? And sometimes you can even have three. So like this example at the bottom for B that has three parts for your piecewise function, all right? So first off, we're going to talk about evaluating piecewise functions. So to evaluate an equation at a certain x value for a piecewise function, first determine which equation you're supposed to plug x into. So for example, let's just get into a problem. So they're saying that we have this function, f of x, is equal to these two equations, and they're defined by these domains. Okay, so they want us to figure out what is f of 0. So evaluate this function when x is equal to 0. So we would say if we plug 0 here, is 0 less than or equal to 2? And we would say yes, so we will use that first equation. If we tried to plug it in here, 0 is not greater than 2, so that function doesn't apply there. So basically we'll have 0 squared minus 1, or negative 1, okay? If we were to plug 2 in here, is 2 greater than 2? No, it's not. But is 2 less than or equal to 2? Yes. So we would plug that into that, again, that first equation. So 2 squared minus 1. So that's 4 minus 1, or 3. So I think C, let's try this one. Is 4 less than or equal to 2? Nope. Is 4 greater than 2? You bet. So we will plug that 4 in for x, or x in for, no, 4 in for x. Let's get those mixed up. So we get 16 plus 1, or 17. All right, so this is how you evaluate piecewise functions. Why don't you pause and give this one a try? So 3. Is 3 between -5 and -1? Nope. Is 3 between -1 and less than or equal to 3? Yeah, 3 is less or equal to 3, so we'd use that middle equation. So 3 minus 1 gives you 2. All right, let's try this 0. Is 0 between those two numbers? Nope. Is 0 between -1 and 3? Yep. So we would do 0 minus 1, which is -1. All right. C, f of -4. Is -4 between those two numbers? Yes. So we would do 2 absolute value of -4. Well, that's just 2 times 4, which is 8. And then last but not least is 5. Well, 5 is greater than 3? Yes. So we would use that last equation. So we would have 5 plus 1 squared, which is 36. All right, so there will be stuff like that on your homework and test, being able to evaluate piecewise functions. All right, the rest of what we're covering today is being able to write piecewise functions. So let's do a quick review. These are the types of functions that you will see on your homework or your piecewise graphs. All right, so it's important to be able to write these equations. So this is a linear equation, so if it's helpful, we could rewrite y equals mx plus b. So what we need to do is we need to find what m is, and we need to know what b is. So again, b is your y-intercept, and m is your slope. So easy to find your y-intercept here, it's 2, and the slope, so we could say b is 2. And the slope, again, we just want to find 2 good points. Looks like we go up 1 over 2, that's 1/2. So our equation would be y equals 1/2 x plus 2. All right, this is an absolute value function, so again, we'll need to find our vertex. Our vertex is 1, 2. And then we need to know what a is. So again, a is we go over 1, and then we'll go down as much or up as much as we need to get to our graph. So it's -1. So y equals, again, I guess I could write our equation for this. Okay, so a is -1, and we'll do the absolute value of x minus h, so -1, and then plus 2. So that's our equation for the absolute value function. And then the quadratic, same sort of thing. We need to find its vertex, which is -1, -6. And then we'll go over 1, up 2, so a is 2. So y equals 2. And then we'll do x minus h, so that's +1, squared minus 6. All right, so if you have questions on those, please let me know. It's gonna be important to be able to come up with your equations from graphs. All right, so piecewise functions. Here is a piecewise function graph. Maybe I should change that to be graph. Okay, write down what you notice. So looking at this piecewise function, you want to maybe think about all the kind of things that we could maybe wonder or think about, any questions you may have. So if you want, pause that and give that a try. So some things that I notice is that there are 3 functions. So we're going to end up having something like 1, 2, 3. I notice that this is a quadratic. So it's going to be something like ax minus h squared plus k. And the second equation, I know it's going to be something like a absolute value of x minus h plus k. And I notice the third one is like mx plus b. Okay. I also noticed that they have certain domains. So each of these functions only apply in certain areas. So like the first one, I know that that only applies when x is less than -3. I also noticed for the second one that it goes from -3 to 2. And then the last one is when x is greater than 2. I also noticed that some of the ends are different. One is open and one is closed. So like this one is like an open dot, and this is a filled-in dot. Okay, what does that mean? Okay, so that means if it's open, that means it doesn't include it. So you don't have it be equal to. But like this point here, that would include -3. And then for the third, this would be when x is greater than or equal to 2. So that's kind of like right there, okay? All right, so that's basically what you're going to do, is you are going to identify the equations that they are, and then also write down where they apply. So let's actually do a problem. So this one we'd probably want to figure out what those numbers are for A and H and K and M and B, okay? So you may want to remember those as you go along. So here's our first example. We have these 2 equations. So what does this look like? And what does that what's that equation? Okay, so this equation is like y equals 3. Okay, and the slope is 0. So any horizontal line is just y equals that y value. Okay, and then this equation looks like it has a y-intercept of 4. So it's y equals mx plus b. So b would be 4. And I don't know what the slope is. Would have to go, what, down 1 over 1. So it's a negative slope, a negative 1. So now we can write down our piecewise function. So f of x is either equal to 3 or negative x plus 4. Now we just need to write down the domain. So the first one, that only applies when x is less than negative 1. Okay, so here's that negative 1. And we're only looking at that side, so x less than negative 1. And then the other side is going to be when x is greater than negative 1. But since this is filled in, it's also equal to negative 1. So there you go. That's our first piecewise function. Let's do another and see if this helps a little bit more. So if you pause, if you need to rewatch that, that's great. Okay, so our first equation looks like we have a vertex of negative 4, 6, and the a value, again, is over 1, down 1, so a is negative 1. So we'll need to write down that equation, but instead of doing y equals, we're going to do f of x is equal to, and then we'll do negative 1 absolute value of x minus h, so plus 4, and then plus k. Okay, and then we want to write down when that applies. Well, that only applies when x is less than negative 1. Our other equation looks like it's a linear equation, has a slope of 1 over 1, and has a y-intercept at 2. So we'd get f of x is equal to our slope, so 1x plus 2 is our y-intercept. But that only applies when x is greater than or equal to negative 1. Okay, so that's another piecewise function. So basically we write down the two equations and then we just need to write down where they apply. Alright, looks like we're going to do 2 more. If you want to pause and give these a try, that would be really great, and then you can kind of see how you're feeling, and if you make any mistakes, then I bet you could figure it out and not make that same mistake on the homework. Alright, so we have 3 functions. F of x is equal to... Okay, so our first one is our quadratic. It looks like it has a vertex of negative 4, 2. And has an a value of negative 1. So we'll just plug that into our equation. So we'll do negative 1, x minus h, so plus 4 squared plus 2. And where does that apply? Well, it applies when x is less than negative 3. Our next equation, this is a linear equation. Again, if it's just a horizontal line, it's going to be something like y equals 5. So this would be f of x equals 5, but that applies when x is between negative 3 and 2. All right, but we want to look at the endpoints. That includes, so we want to do less than or equal to. Okay, and then the last one is an absolute value function. Looks like our vertex is 3, 2. And the rise over run is over 1 up 2. So a here is 2. So 2 absolute value of x minus 3 plus 2. And that applies whenever x is greater than or equal to 2. So here's that domain that we have that kind of cuts that graph out. Or like, yeah. Okay? All right, last one. This looks like we have another equation where we have 3 functions. First one is an absolute value function that has a vertex, -3, 2, and we go over 1, down a half, so down -1/2. Okay, so we would write our equation, so -1/2 absolute value of x plus 3 and then plus 2. When that applies, well, that's when x is less than -1. Next is a linear equation. It looks like it has a y-intercept of 4 and a slope of -1, so it'd be like y equals -1x plus 4. And that applies when x is between -1 and 2. And both of those are filled in, so both of them would be less than or equal to. So I should put in these commas. And then the last one is a quadratic, has a vertex at 4, -1, and then it goes over 1, up 2. So a would be 2, x minus 4 squared minus 1. And then it applies between, x is between 2 and 5, but it includes 5 because it's a filled-in dot. All right, so that is basically it. I know this is kind of a little tricky because you're like doing what, like multiple equations that you have to write down and then figure out what their domains are. If you have any questions, please let me know. You may want to go over these problems again. Our next lesson is we're going to go the opposite. We're going to, given the function, the piecewise function, we're going to graph. All right, we'll see you later.